Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Let's try the 2015 cubic equation. This was actually worth a full 25 marks, so it was great if you knew how to do it. Solve the equation x cubed minus 3x squared minus 9x plus 11. So the other two types of this that we've done have told you one of the roots. This one doesn't. So you have to deduce or figure out by trial and error what the roots are. The only clue is that one of the roots will be a factor of plus 11. Okay, so factors 11 is a prime number. I would try x is equal to 1. So you'd have minus 1 minus 11 plus 1 plus 11. So I definitely try 1 and minus 1 as my first two. So let's try x is equal to 1. So I'd have 1 cubed minus 3 times 1 squared minus 9 times 1 plus 11. So let's put that into my calculator. 1 minus 3 minus 9 plus 11 is indeed equal to 0. Okay, therefore x is equal to 1 is a root or a solution, whichever you want to call it. And x minus 1 is a factor. Okay, so you can do the next part in two ways. You can do a long division, or you could equate coefficients. So I might do it both ways just for this example to show you what I mean, just in case there's anybody who doesn't like long division. But we'll do long division first. So it's always the factor that you long divide in to the cubic. You'll get a quadratic, you'll solve the quadratic, and that will be your other two roots. Okay, so I'm just going to get rid of the brackets there. Okay, so what must I multiply by x to bring it up to x cubed? Well, you need another two x's, so an x squared. And you multiply that by everything on the outside. So x squared by x is x cubed. X squared by minus 1 is minus 1x squared. Put a line under it, and then you subtract or change the sign to get the difference. So change the sign, they cancel. Minus 3x squared plus 1x squared is minus 2x squared. Okay, we take down minus 9x plus 11. Okay, and you do it all over again. What must I multiply by x to bring it up to minus x squared? We don't consider the minus 1 in this part because it's too hard to work with both numbers. So we just work with the x. So what must I multiply that to bring it up to minus 2x squared? Well, I need the minus, I need the 2, and I need another x. Okay, and we multiply that minus 2x now by everything on the outside. So minus 2x by x, minus 2x squared, minus 2x by minus 1 is plus 2x. Put a line under it, change the sign, and then I have minus 2x plus 2x is cancelled. Minus 9x minus 2x is minus 11x. And take down the plus 11. Okay, what must I multiply by x then to bring it up to minus 11x squared? And I'll need a minus 11 up the top. And I multiply that by both bits on the outside. Minus 11 by x is minus 11x. Minus 11 by that is plus 11. Put a line under it. Change the sign, cancel, cancel, and I get 0. Okay, so my roots, my other two roots are contained within x squared minus 2x minus 11. Okay, so at this stage, you are looking at 11 and you're thinking about the factors of 11 because it is a prime number, so it's only two factors, 11 and 1, and you can see neither of them is going to give you -2. So I'm thinking factorising isn't going to work. The other clue that factorising wasn't going to work and you needed the -b formula was here in how they want their solutions. They've called them irrational, which means there's a square root sign in them, typically when it's quadratic, and they want them in the form a plus b root c. Okay, so that's their hint that you're going straight for that -b formula because it's not going to divide in. So a is 1, b is -2, c is -11. Okay, so x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, your log tables, you don't have to remember it. It's there at the top of page 20. Okay, and it tells you which is a, which is b, which is c. So x is equal to -b, so it's -2 plus or minus the square root of b squared, so -2 squared minus 4ac all over 2a, which is 2 ones. Okay, so it's equal to -2, which is 2, plus or minus, popping on my calculator, the square root of -2 squared minus 4ac. I'm getting 4 root 3 over 2 ones are 2. Okay, so how you do this is you divide both bits by the 2. So I'll have 2 over 2 plus or minus 4 root 3 over 2. Okay, so all I've done literally is split them out like that and split them out like that because it's nearly easier to see now that 2 over 2 is 1 plus or minus 4 over 2 is 2 root 3. Okay, so my solutions, don't forget the x is equal to 1, okay, because this one said solve, so it's expecting values. You can write it as x is equal to 1 plus 2 root 3 and x is equal to 1 minus 2 root 3, or you could have written it as x is equal to 1 plus or minus 2 root 3. Any of those would be the same. So that's how I would do it with long division. What I want to show you now is an alternative to the long division part. In other words, how could I get this quadratic, or could I in any other method? And you can with, let me just copy this, the question. You can with equating the coefficients. So let's give that a bash and hopefully it'll work out for us. Okay, so if I was to do this with equating the coefficients, I would still have to work out, try x is equal to 1, 1 cubed minus 3 times 1 squared minus 9 times 1 plus 11, and show that that was equal, and therefore x minus 1 is a factor. Okay, so that bit didn't change. That was the start here for the question. Okay, so equating the coefficients then, how does that work? Well, I know if I take that factor I now know and I multiply it by the quadratic that I know I'm going to get when I long divide it in. In other words, when you multiply this root by the other two roots, which are contained within that quadratic, you are going to get x cubed minus 3x squared minus 9x plus 11. Okay, so you might be asking now, is this going to be much harder or easier than long division? Well, let's have a look and let's see what happens. So x, I'm going to multiply x by everything in the second bracket and then go back for -1 by everything in the second bracket. Okay, so x by ax squared is ax cubed, x by bx is bx squared, x by the c then is cx. Now, -1 by ax squared is minus ax squared, -1 by bx is minus bx, -1 by c is minus c. And we know that that has to be equal to my cubic equation. Okay, and you equate the coefficients now. So in other words, you let the cubic parts equal the cubic parts, you let the squares equal the squares, you let the x's equal the x's, and the number equal the number. Okay, because it has to be that way if they're equal. Okay, that is the only way the left can equal the right. If the coefficients in front of x squared here, for example, equal -3. Okay, so how do we do it? Well, you generally write down your x cubes first. So ax cubed is equal to the x cubed on this side. You can cancel the x cubes then. So now I know that a is equal to 1. Okay, now I'm going after the squares. Okay, so bx squared minus ax squared must be equal to -3x squared. Cancel out all the x squares. So b minus a is equal to -3. I know from here that a is equal to 1. So b minus 1 is equal to -3. Bring over the -1. b is equal to -3 plus 1. b is equal to -2. Okay, that wasn't too bad. Now let's go for the x's. So there's an x, and there's my x. So I have cx minus bx is equal to -9x. Cancel out the x's. C minus b is equal to -9. I know b is -2, so c minus -2 is equal to -9. C plus 2 equals -9. Bring him over. C is equal to -9 minus 2. C is equal to -11. Okay, he's good. And then the numbers, minus c is equal to 11, or c is equal to 11. -11 even. Okay, so obviously it should match. It should match what I have there. So therefore, I can now write down my quadratic. Remember my quadratic? I called it ax squared plus bx plus c. Ax squared plus bx plus c equals, well, my a is 1, so that's x squared. My b is -2, so that's -2x. And my c is -11. Okay, so you can see the exact same quadratic, of course it is, that we got when we did long division. And then you solve it using the -b formula, of course, and you get the same solutions. So equating the coefficients is an alternative to long division for these type of questions. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.